So,
Yes, Aryan, you have give the introduction your side, then you have to start your presentation.
so I think so. Shall we start now? Just wait a minute. Um, Wait. So, hello everyone. My name is Aryan. My father's name is Dhavin Kumar. I'm studying in sixth grade, and today we are going to talk about general relativity and special relativity. So, what is the difference between them? And we are going to see what are the practical uses and how it helps us to progress more and more. So, yes. So, introduction to relativity. So, relativity is a theory developed by Albert Einstein in the early 20th century. It consists of two main theories: special relativity and general relativity. Together, they revolutionized our understanding of space, time, and gravity. So, yes, it is a theory of space, time, and gravity. So, Aryan, can you read this slide for everyone? Hello, Aryan.
Hello, yes.
Can you read this for everyone?
Yes. Historical context. Before Einstein, Newton physics dominated the understanding of motion and gravity. The early 90s saw a need to reconcile electromagnetic theory with classical machines. Einstein theory emerged from the need to explain phenomena that Newton physics could not.
Okay. So, before Einstein, Newtonian physics dominated the understandings of motion and gravity. So, the early 90s saw a need to reconcile electromagnetic theory with classical mechanics. Einstein theories emerged from the need to explain phenomena that
Oh,
Newtonian physics could not. So, yes, it it
the
was the
context
time
of
of Einstein.
the
What
thing
happened?
is need to the
What happened that there were some problems with Newtonian physics that they
example
cannot
from the
understand it.
Newton is called.
I think so. Someone has a question. Okay, I don't think so. So yes, today right now we are going to talk about it. So special relativity overview. So the special relativity was introduced in 1905 and focuses on
The ways of two.
reference. It is based on two postulates. It the consistency of the speed of light and the principle of relativity. The theory fundamentally challenged the concepts of time and space. So yes, this was introduced in 1905 and focuses on the initial frames of references. So I think so. It is the main thing that they are talking about is that the space and time are not what you call two separate entities, they are together. So that is called space time, and that is shown in the picture given. So yes, ladies and gentlemen, any questions for me? Okay, I don't think so. So special relativity, so it is a fundamental theory in physics that describes the behavior of an object when they move at constant high speed relative to each other. So, many key principles are there that the speed of light is constant, time dilation, length contraction, the laws of physics are the same everywhere. So, yes, re- So yes, these are some key principles of special relativity. The speed of light. So yes, the speed of light in a vacuum is constant and does not change irrespective of the observer's motion. So yes, I think so. Someone has raised their
Yes,
hand.
Aryans, many of new person join now. So first of all, you have say the greetings to everyone,
So yes.
and try to give the short introduction your side. Then you have to brief a little bit your side about the your presentation.
Okay. So many new people have joined. So if you have any questions, you can raise in hand. And thank you for joining us. So right now we are discussing about Einstein theories, special relativity, and general relativity. Right now we are on the topic of special relativity, and yes, moving to a topic. So this principle leads to the conclusion that time and space are interconnected. Observers moving at different velocities will measure time and distance differently. So, does anybody have a question? Yeah, I don't think so. So, like, take one thing. If you are near a black hole and there is another observer, like your friend is there, and you're seeing him, that when he goes close to the black hole, he will, what we call, uh, after some time, he will disappear, just fade away, and he will see that you are slowing down and just disappear, but your perspective, but his perspective would be like the time is moving same for him also, and but the observer's view is changing that. So yes. So Aryan, do you have any questions? So yes, Aryan, what's your question? Hello
In
Aryan.
future, my question is, in future we can travel speed of light.
So Einstein theory says that nothing which travels at a finite speed can reach speed of light, but it does not forbid faster than speed of light. So yes, that can mean if you want to go higher at the speed of light, you will. There is one hypothetical thing, tachyons. They say that they move faster than the speed of light and will forever move at that speed only. So yes, Einstein theories do not forbid faster than light motion. So yes, I think so. Someone else has raised their hands also.
So, Aryan, I don't know about humans, but I know about the missiles. They travel 3 times faster than light.
I think you are talking about speed of sound, cause I don't think so. We have that level of technology. You are maybe mentioning 3 Mach. So 1 Mach equals to the speed of sound. And yes, we have made many things that are faster than this. So Agni 5, it is the missile of India, which is traveling about 24 times the speed of sound. I am mentioning sound here, not light. So yes, the thing that you are saying that it travels 3 times faster than light, it is not true. That can be in Mach, which is the speed of sound. So yes.
It is the Russian missile can.
Okay, I think so. It would be traveling at 3 to 5 Mach or 3 to 5 times the speed of sound. So yes.
I'll confirm and get back to you.
Okay, it would be Mach. Uh, our topic is time dilation. So time dilation is a phenomena where time passes at different rates for observers in different frames. So a moving clock ticks slower compared to a stationary clock from the perspective of an observer. So this effect has been confirmed through experiments such as those involving fast moving particles. So it is the phenomena where time passes at different rates for observers in different states of motions. So some key points, that speed of light and time measurements and the twin paradox. Some examples are the twin paradox and the GPS and time dilation. So one twin travels at high speed relative to the other twin, resulting in time dilation. So when the traveling twin returns, they would have aged less than the stationary twin, and GPS and time dilation. So GPS satellites must account for time dilation caused by their high speed motion and position in weaker gravitational fields. If not corrected, this would result in errors up to 10 kilometers a day. So yes, this thing is real, and if you are in a very high gravitational field, what happens that the time for the other observer observing you will go slow, but your perspective it would be the same. So yes, this is time dilation, and it is also caused by high moving objects. So yes, if you are moving at the speed of light, the time for you will almost stop. So yes, this is the thing proposed by special relativity. So any questions for me, Arif? Okay. Arif, what's the question?
I saw one video that is telling if we that is at there is atom clock and one is on land and one is traveling in plane. When they were land plane and they compare their time were different. Why this thing happen?
So yes, that is true, but I don't think so. I have a question for why that happens. I think so because of space-time curvature that happens. It affects time, gravity, etc. So yes, maybe because of space-time curvature. We will discuss it later in this presentation. So okay. So Aryan, should we move to the next topic?
Yes.
Okay. So our next topic is length contraction by special relativity. So length contraction states that objects are measured to be shorter in the direction of motion. So this effect becomes significant as an object's speed approaches the speed of light. So length contraction is not noticeable at everyday speeds, but it is an fundamental aspect of relativity. So it is the phenomena where an object appears to be shorter in motion relative to the other objects. Okay. So yes, this happens at very high speeds. You will see th- that the object you are measuring is a little bit smaller. Mass energy equivalence. So Aryan, can you read this for everyone?
Yes.
Okay.
Mass energy equivalence. One of the key outcomes of special relativity is the equation equal mc2 This equation expresses the equivalence, the mass and energy, indicating that they are individual. It suggests the small amount of mass can be converted into a large amount of energy.
Okay.
And I have one question
What's the question?
that is related to fire. One time I saw when my near gully some children are burning a spoon of plastic. Then I saw the fire was sky blue color. Then what is temperature of sky blue color fire? Be- Because blue is the hottest. Then what is sky blue?
The temperature of sky blue color. So I think so around. mm, I think I do not have an answer for that. I will what can call tell you after this class, right?
Okay.
Mass energy equivalence. So one of the key outcomes of special relativity is the E equals mc square 2. So this equation explains the equivalence of mass and energy, indicating that they are interchangeable. It suggests that a small amount of mass can be converted into a large amount of energy. So, so E is the energy, M is the mass, and C is the speed of light, and the 2 is the squared. So yes, let's take an example. If I have 100 kgs of uranium and the mass defect of that is maybe 1%, so 100 kgs would become 1 kg, and if I put that into this equation, so that would become 9 multiplied by 10 raised to the power of 16 joules of energy. So yes, this is the key outcomes of the special relativity. And yes, this thing can is real, and some examples are the nuclear power plant, particle accelerators, stars, and supernovas. So yes, this is the mass energy equivalence. E equals to mc square 2. So ladies and gentlemen, any questions for me? Okay, Aryan, what's the question?
What is meaning of equal MC2?
So E equals to the energy, M is the mass, and C is the speed of light, and squared is you multiplied by the same number. So did you understand now?
Yes.
Okay. Okay. So yes, we are now finished with special relativity. Moving to the next topic, it is about general relativity overview. So yes, Ryan, can you read this one for everyone?
Yes.
Okay.
General Relativity, published in 1915, extends the principles of special relativity to include gravity. It describes gravity not as force but as the curvature of spacetime caused by mass. This theory provides a more comprehensive understanding of gravitational phenomena.
So, okay, general relativity. So it was one of the most groundbreaking and influential theories in modern physics, developed by Albert Einstein. So general relativity is a fundamental theory that describes the nature of gravity, space, and time. So that gravity is not a force but rather the curvature of space-time caused by massive objects. So yes, and predictions of these are gravitational time dilation. Time passes slower near objects due to their stronger gravitational field. Gravitational redshift. So light is shifted towards the red end of the spectrum. It escapes from a region with strong gravity. Gravitational waves and black holes. So yes. So experimental evidences are the bending of light. So the bending of light around massive objects such as stars and black holes confirm the curvature of space-time. So, ladies and gentlemen, any questions for me? Okay, I don't think so. So, Aaron, would you like to read this slide?
Yes. Space-time concept. Space-time concepts the dimension of the space with the dimension of time into a single four-dimensional continuum. Massive objects like planet and star wrap the fabric of space-time around them. The curvature influences the motion of other objects, leading to the fact we perceive as gravity.
So yes, so yes, space-time concept. So it combines the three dimensions of space with the dimension of time into a single four-dimensional continuum. So yes, massive objects like planets and stars warp the fabric of space-time around them. So this curvature makes the illusion of gravity. So it is a four-dimensional fabric that combines space and time. So it's the arena where all physical phenomena take place. So some key features are curvature and the four dimensions. So theory of general relativity. So this theory describes the space-time continuum has a dynamic curved fabric. According to this theory, gravity is a curvature. Some implications are GPS technology, black holes, and cosmology. So yes. Does anybody have any questions? Okay, I didn't what's your question?
Can we do time travel for one day?
Can we do time travel?
Huh.
Mm, so it is a very fascinating and debated topics in physics. So according to time dilation, so time dilation occurs when an object moves at high speeds or is placed in a strong gravitational field. So this will cause time to move slower for all objects. So maybe a little bit. Maybe
No.
let's say a little bit can happen, but it needs a very high gravitational field, etc. So, like if you go near a black hole, the time for you will slow down. So, yes, you can take that as a literal evidence of tra- time travel.
Human can do. By there are two country in between there are two small islands, and in winter there are two rivers. They are when frozen, then we can do time travel of one day.
And do you see that it is the time created by ourselves? So, I think so. You are talking about longitudes and latitudes. So, yes, you can also say that it can work. but you would need a very fast flight to do that. So yes.
No, we can walk. In winters, we can walk and go through the opposite line, and we can do time travel of 1 day.
Okay. So so I will research about that and move into a next topic. So Aaron, would you like to read this? The equivalence principle.
Yes, the equivalence principle states that the local observations in a freely falling elevator are indistinguishable from those in deep space without gravity. This principle led Einstein to conceive the gravity as geometric property of space-time. It has profound implications for underestimating gravitational effect on time and space.
So okay, that the equivalence principle states that the local observers in a freely falling elevator are indistinguishable from them from those in deep space without gravity. So this principle led Einstein to conceive gravity has a geometric property of space-time. So it had profound implications for understanding gravitational effects on time and space. So the equivalence principle states that the gravity is equivalent to acceleration. So the effect of gravity are equivalent to the effect of an acceleration. So an observer in a gravitational field will experience the same effect as an observer who is accelerating in a rocket. So yes. So implications of the equivalence principles, that gravity is not a force. The equivalence principle suggests that it is not a force that acts between objects, but rather a, a illusion caused by the curvature of space-time. So yes, and the gravitational redshift, the equivalence principle predicts that light emitted from a source in a strong gravitational field will be shifted towards the red end of a spectrum. So this thing states this is the equivalence principle. So does anybody have a question? Mrityunjay Bhaiya, do you have any questions?
No, no, Aryan, you continue.
So do you want to add something?
As of now, I don't know if anything is needed to be added here.
Okay,
You can
thank
continue.
you. Okay, so Aaron, you have raised your hand.
I have a question.
Okay, what's the question?
In that when India are going to launch when ISRO is going to made India's rocket first going to two people that would step on moon.
Okay, I think so. You are talking about talking about ISRO's future missions. So yes, that would happen. I think so, and missions are going. So yes,
When they are going to send people on moon.
I don't know. I think so. Many. Okay, I think so. Many people have joined. So yes, and I have already. somewhat talked to the ISRO scientist around what we call the launch when Chandrayaan 3 was going to be launched. He said that they are working on another mission on sending the humans into low Earth orbit or the Gaganyaan. So yes, that was the mission he told me about, and it had already happened. So yes, I think so. Nikhil ji has also joined. So thank you for joining. So if you have any questions, you can raise in hand to ask. So yes, thank you. So uh, Ryan, would you like to read this?
Yes. Predictions of general relativity. General relativity has made several predictions that have been extremely verified. These include gravitational time dilation, the bending of light around massive objects, and the existence of black holes. Such predictions have been confirmed through observations and experiments, so- solidifying the theory's credibility.
So yes, predictions of general relativity. So yes, general relativity has made several predictions that has been experimentally verified. These include gravitational time dilation, the bending of light around massive objects, and the existence of black holes. Such predictions have been confirmed through experiments, observations, solidifying the theory's credibility. So, Aryan, you have raised your hand.
I have two questions. My first question is why Newton Tesla is named Newton Tesla. It can be Newton. Then why people add in her name Tesla?
I didn't get your question.
I am telling that why people are saying Newton Tesla to Newton Tesla. It can be Newton. Then why people say Newton Tesla?
Yeah, I don't. Mm, I think so. You are referring the units of measurements of the magnetic field, Newton and Tesla.
No, I am asking why people say Newton Tesla to Tesla. It can be Newton only.
Okay, I think so. I will answer that question after the class. I am not getting that question. And what's the second question, Are?
Which has have more IQ, Newton Tesla or Albert Einstein?
So I don't think so. I have an answer for that. Mm, I don't know about that. I think I will tell you the answer after the class.
Okay.
So yes, we were on the topic predictions of general relativity. So, gravitational phenomena, gravitational redshift. So, light emitted from a source is a strong gravitational field is shifted towards the red end of the spectrum. So, gravitational time dilation. So, time passes slower near objects due to their strong gravitational field. Then, gravitational lensing also, the bending of light around massive objects such as galaxies and galaxy clusters. Astrophysical predictions, black holes, neutron stars, white dwarfs, and the cosmological expansion of the universe. So, yes, and some experimental confirmation, gravitational lensing, gravitational waves, and gravitational redshift. So, yes, this is the prediction of general relativity that happened to be true. So yes, ladies and gentlemen, any questions for me? Okay, I don't think so. So yes, moving to our next topic, black holes. So, Aaron, can you read this one?
Yes. Black holes are regions of space-time where gravity is so strong that nothing can space escape from them. They are formed when massive stars collapse under their own gravity after executing their nuclear fuel. The event horizon marks the boundary beyond which no information can be escaped, a black hole.
So, black holes. What's the question, Aaron? And Ryan also?
That
Are
is
there multiple black holes, or are there only one black hole for each star?
No, no, I think so. You misunderstood that black holes can be formed when stars die. It matters how much weight the star had, and each galaxy has one black hole at its center because the density there is very high. So yes, did you understand, Ryan?
I thought that every solar system has its own black hole.
No, no. So
Okay, thank you.
okay, Aaron, what's your question?
in this slide in the given picture what you have written in that Japanese or Korean or Chinese.
Okay, I have taken a picture from the internet. So first one is of the star, the second one is a neutron star, and the third one is of the black hole.
Okay.
So yes, so there are many types of black holes. So stellar black hole, supermassive black hole, and intermediate mass black holes. So some characteristics of black holes: event horizon, singularity, and the egosphere. A region around the rotating black hole where the gravity is so strong that it can extract energy from the object and enter it. So, formation of black holes, stellar collapse, and mergers. So, yes, this is moving to the next topic. Okay, so now we are moving to the next topic. It is about gravitational waves by relativity. So, yes, Aaron, would you like to read this one?
Yes. Gravitational waves. Gravitational waves are ripples in space-time caused by accelerating massive objects such as mean merging black holes. Their existence was predicted by general relativity and confirmed by LIGO in 2015. The dedication of gravitational waves opened a new era in astrophysics, knowing as other cosmic event.
Okay. So, gravitational waves are ripples in spacetime caused by accelerating massive objects such as merging black holes. Their existence was confirmed by general relativity and confirmed by LIGO in 2015. So, the detection of gravitational waves opened a new era in astrophysics, allowing us to observe cosmic events. So, yes, I think so. Many new people have also joined. I think so. There is Uh, Nishant Khan. So, can you introduce yourself? Nishant Khan. There are many new people. So, okay. Okay, I think so. He's not here. So, yes. Few people, new people have also joined. Celine Sophie has also joined. I think so. She had already introduced her in our previous classes. So yes, moving to a topic. So gravitational waves. So these are just some ripples in space-time caused by accelerating objects. Like take a black hole and a neutron star. If they collide, gravitational waves will happen. So it is a groundbreaking discovery that opened a new window into the universe. These are ripples in the fabric of space-time produced by the acceleration of massive objects such as binary black hole mergers, neutron star mergers, and supernova explosions. So yes, Aryan, what's the question?
I saw in internet that there is again a virus is coming. I forgot her name, but that is can distribute by air and more dangerous than corona, and that is found by Japan's lab mistake. Is that is true?
I do not have any idea about what you're talking about, but yes, I think so. I will research and give you the answer by the next class.
Okay.
So yes, moving to a next topic. So, experimental evidence. So, general relativity has been confirmed through numerous experiments and observations, such as the bending of light during a solar eclipse. The GPS system accounts for both special relativity and general relativity to provide a accurate positioning data. So, observations of binary pulsars have also provided strong evidence for the predictions of general relativity. So the GPS system we are using, it is the product of general relativity and special relativity. So yes, thanks, thanks for both of them for providing the GPS system. So relativity in modern physics. So both special and general relativity have influenced modern physics and cosmology significantly. So these are foundational for understanding the universe and have implications for particle physics and cosmological models. So the theory helps explain phenomena from the behavior of subatomic particles to the dynamics of galaxies. So yes, this thing, this thing, it is very used in modern physics. So, Mrityunjay Bhaiya, do you have any questions? Okay.
No, Aryan.
So, do you want to add something?
No, I don't want to add something here, but I want to answer other Aryan's question.
Okay.
So I think he had two questions, out of which one I remember. That one is he saw someone burning plastic and he saw a blue flame, and he told that he wanted the temperature of the flame, as he thought that blue flame has higher temperatures, but that is not the case here. They are burning. They
Yes,
are
yes.
burning. Yeah.
Because there are some chemicals, if you what we call pour in the fire, it can change the color of the flame. So,
Yes. Yes.
it's okay. Anything else?
No, I think he had one more question that you told to answer after the class.
Okay, I think so. Hmm, I think so. It was about some virus. I think so.
No, no, no. Before that.
That is why Newton Tesla is called Newton Tesla. It can be Newton.
Yeah, actually, they both are different scientists. Tesla, I think he was, I think, before Newton. Probably. I don't know. I don't know timeline. I'm not sure about the
Newton,
timeline.
I think so.
Yeah?
After Newton, I think so.
Yeah, I'm not sure about a timeline. But yeah, they both are different. Newton was completely into mathematics, and Tesla was somewhat into a field of engineering. So
Yes.
both were doing physics, but somewhat different fields.
Yes. And one more question was there. Is Newton Tesla smarter than Einstein?
We can't judge that.
Yes.
We may have the IQ numbers and everything, but that doesn't show the actual stats of a person.
Yes. So, yes. So, yes, moving to a topic. So, some common misconceptions of special relativity and general relativity. So, some things is that relativity means everything is relative. However, the principles are based on specific laws. So another misconception is that gravity can be cancelled in free fall while it is actually experienced differently. So understanding these misconceptions is crucial for grasping the true implications of relativity. So yes, so nothing can reach the speed of light. Actually, it's impossible for the object with mass to reach the speed of light, but it is possible to approach the speed of light. Like you can go at 999.99% the speed of light, but you will never reach it. So time dilation means actually time slows down. Length contraction means object actually shrinks. And special relativity only applies to high object speeds. So it applies to all objects regardless of the speed. And length contraction actually means object object shrinks. So like time dilation, length contraction is a relative effect. Objects don't actually shrink, they just appear. Time dilation means time actually slows down. So it is a relative effect and does not actually slow down. It's just that time appears to pass differently for the observers. So yes, these are some misconceptions and challenges to relativity. So despite its success, general relativity faces challenges with particularly in reconciling with quantum mechanics. The conquest for a quantum gravity aims to unify these fundamental frameworks. So these are exploring various approaches, including string theory and new quantum gravity. So Aryan, what's the question?
Uh, since there was some, the scientist in a machine, something speed of light near, they they collapse to Pluton. Then it release around temperature 5 trillion. That is true.
I think you are talking about the Large Hadron Collider where two particles collide with high speeds. Yes, the temperature would reach that. So it is very much.
Then why Pluton release this much temperature?
What are you talking about?
Then why Pluton released that temperature?
Okay.
When they collab, then why how they can release around that temperature?
So when what happens that they are collided with absolutely near the speed of light, which is too much, and when they collide, what happens that the temperature starts increasing, and yes, 5 trillion Celsius it is. It happens. Yes.
So if we can collab other particle, then it can release same temperature.
Yes. Yes, and when that would collide, it would may break into smaller particles.
Okay.
So yes. So future of relativity. So the future of relativity in research includes exploring the limits of the theory and testing its prediction in extreme conditions. So new technologies such as advanced telescopes and detectors will facilitate deeper investigations into gravitational phenomena. Understanding dark matter and dark energy may also require new insights from relativistic frameworks. Some conclusions. So, general and special relativity remain cornerstones of modern physics, reshaping our understanding of the universe. Their predictions may have been confirmed by a multitude of experiments and observations over the last century. Continued research in relativity holds the potential to unlock further mysteries of the cosmos. So, yes, thank you for joining, everyone. I hope you liked this. So, yes. So, did everyone like that? Hello, Aryan.
Yes.
So, yes. Do you have any extra questions?
I asked some question. You say you will answer after class.
Yes. So, so does anybody wants to add something?
No, we can leave now.
Okay. Yes.
Yeah, I just want to add something.
Yes. What's
Yeah,
the question?
no, it's not about the question. Uh, First, I would like to thank you for the wonderful presentation you have given. It's a very nice topic,
Okay.
and I just want to make an announcement here, a small announcement.
Okay.
We are conducting a quiz with Starlight Seekers, and it is on 26th of this month. So, you will get a participation certificate and a merit certificate as well by when you participate in the quiz. So you can write the quiz in the Cosmic Buzz app. So I just want to make this announcement that everyone in the call can could join that quiz and participate in the quiz,
Okay.
including you, Aryan.
Yes.
Yeah, that is what we I want to give. And there is one more update. We have recently launched Cosmic Buzz latest update. It will be live tomorrow by tomorrow, so you can update your app and you can enjoy more features. The astronomy career webinars also has been uploaded in the app, which was conducted latestly by Suryansh. So you can view that webinar as well on the app.
Okay. Thank you.
Yeah.
So yes. So Mrutyunjay bhaiya, do you have any questions?
No, no, Aryan.
Okay. So do you want to add something?
I just want to say that today's presentation was good. Like you presented very well. That's such a complex topic, and I liked it.
Yes. So
Oh, yes, Aryan. Thank you so much for your great effort. Okay, you're such a
Yeah.
small boy, but you put the effort. Thank you so much.
Thank you,
Keep
ma'am.
it up.
Thank you, ma'am. I think so. Few new people have joined. So Permi Shiva has joined and Hari Jamwal. So thank you for joining, everyone. I hope you liked it. So yes. So does anybody wants to add something to my presentation or any questions?
So Aryan, first of all, you have give me once again some new person like the Shivaji also joined, and some maybe all person know you, and a new person is joined Shivaji. So can you introduce a little bit your side, Premi Shivaji? So not an issue. So thank you so much everyone to join this sessions. Aryan is sixth grade.
Navin bhai.
Ji, ji, yeah.
Yeah, actually, I would like to add one more point here.
Yes, yes, please, please.
Yeah, actually, NASA is conducting Hubble Night Sky Observation Challenge. So, if anyone have telescopes with you, you can observe the night sky and take your pictures, and you can post that in that challenge. I have already posted that article in every group, so
Okay.
you can go through that and
बट आर्यन है टेलीस्कोप बट पता नहीं कैसे उसको क्लिक करना है
okay, okay,
बट वो
no
उसको
issues. You can try.
उसको हाँ बट
Yeah,
he has to try.
yeah,
हाँ
it's a nice challenge actually. I have also given every information and links in the app as well,
yes
so you can
yes
go through them.
Aryan, so you can read carefully na. I have clicked the picture in this location. Actually right now I'm in Rajasthan, so here sky is totally clear. I can see all things like the very clear way. So Aryan, I can click the picture and then send to you. So you have to prepare and send to the NASA.
Okay.
Okay.
Yeah,
Okay. Thank you, Nikhil Bhaiya. Thank you so much for
yeah, yeah.
joining.
Okay, no issues.
So Aryan is improving day by day, and thank you so much everyone to join us. And Aryan is sixth grade. He is much interested about the science, and he's taking the many classes from the scientists also like the Wawa Atomic Center, and sometimes he also talk with the ISRO scientist. So he is curious about the science. Always he's read many books, and some many people is also guide like the cosmic box team, imaging, and other also. So we are also once again thank you so much. And next Sunday we will also join and 11 o'clock same time. And if anyone want to add something, you have any questions, so please talk with Aryan. And Aryan also have a on WhatsApp group, so he has also updated a little bit in group also. So I have also posted in the group link in a chat box. You have to join if you if you want to join. Okay, Aryan, thank you so much. Up you have to prepare next your presentation, then send to the Nikhil Bhaiya and Mrityunjay ji. I have just sent your PPT also. If anyone want to
Yeah,
PPT,
yeah.
please let me know. I am just send to you. Don't worry.